When we think of artificial intelligence, we imagine something weightless, a digital brain floating in the cloud. But that cloud is tethered to a massive, humming concrete reality, built directly in the middle of the most drought-stricken regions in the United States. Every time you type a prompt into an AI chatbot, a physical transaction takes place. Researchers estimate that generating a single 100-word response requires enough server cooling power to consume a standard half-liter bottle of fresh water. This is a chart showing projected water demand for US data centers. By multiplying those single bottles across millions of users, the scale becomes staggering. In 2023, data centers consumed roughly 17 billion gallons. By 2028, as the AI arms race accelerates, that demand is projected to surge to 73 billion gallons every single year. To see what that looks like on the ground, look at Newton County, Georgia. A single metadata center located there pulls in 500,000 gallons of water a day. That one facility accounts for 10% of the entire county's water consumption. The illusion of a weightless digital future masks a heavy industrial extraction process. Tech giants are expanding their physical footprint exactly when many local communities are being forced to ration their remaining supply. These facilities require vast amounts of water for a simple mechanical reason. Specialized AI processors generate extraordinary heat. To keep servers from melting down, hyperscale data centers rely heavily on evaporative cooling systems that constantly cycle and vent freshwater. Tech companies are trying to engineer their way out of the problem. Microsoft, for example, is developing closed-loop liquid systems that are filled once and continuously circulate the same fluid. Others are experimenting with immersion cooling, where servers are completely submerged in specialized synthetic oil. But these alternatives face massive hurdles. Immersion cooling is prohibitively expensive to scale, and closed-loop systems require a massive increase in electricity to operate, which indirectly consumes even more water at the power plant level. Most importantly, these upgrades simply aren't being rolled out fast enough to outpace the aggressive construction of new data centers. If engineers cannot build their way out of this deficit, the focus has to shift from the hardware to the law. We have to look at the legal framework that allows a private entity to endlessly siphon a dying public resource in the first place. This raises a legal question. Under global property law, natural waterways are protected as public trusts. So how exactly does a multinational corporation go about buying up a town's water supply? You can't actually buy a physical river. In 2003, a billionaire named James Cox Kennedy tried to do exactly that by buying the land surrounding Montana's Ruby River and fencing off the bridges. The courts ruled against him, reaffirming that private wealth cannot barricade a public waterway. Instead of buying the water itself, corporations purchase what are known as usufructuary rights. They acquire a legally protected permit to extract and use a specific volume of that public resource. By separating the legal right to the water from the physical river itself, corporations can control a region's lifeblood without ever needing to own the landscape it flows through. In regions like California and Colorado, this separation goes further under the doctrine of prior appropriation. Here, water rights are completely severed from land ownership. They're governed by a strict permitting system where the first person to claim the water holds senior rights, and those rights can be bought, sold, and traded as independent assets. This legal severability reached its peak in December 2020, when water futures were traded on Wall Street for the first time in history. The CME Group launched financial contracts directly linked to the Nasdaq Veles California Water Index, meaning speculators could now bet on the future price of California's water scarcity. The architects of the market argue this provides a hedging mechanism. In theory, a farmer anticipating a severe drought can buy a futures contract to lock in a price. If physical water becomes too expensive to pump later that summer, the farmer can sell their contract and use the financial profits to offset their farming losses. The risk is that water is not a standard commodity. When hedge funds and investment banks pour speculative capital into these futures, they can drive the index price up. Because that index influences the expectations in the physical market, Wall Street speculation can artificially inflate the actual spot price of the water flowing to a municipal facility. Turning human survival into an asset class detaches resource management from human rights priorities. It creates an environment where investors can profit directly from ecological desiccation, driving up the cost of global food security. While corporations and communities clash over local aquifers, the scale of the crisis expands when sovereign nations compete for control over shared river basins. Tensions are accelerating across shared transboundary river basins. On the Nile, the construction of the Grand Ethiopian Renaissance Dam has created a massive physical choke point upstream, straining diplomatic relations by threatening Egypt's downstream water security. Similar fractures are appearing globally. The decades-old Indus Waters Treaty is struggling to manage modern demands between India and Pakistan, while unilateral dam projects in the Euphrates-Tigris basin have led to accusations of upstream nations weaponizing the water supply against their neighbors. These regions face a volatile mix of outdated treaties, rapidly growing populations, and climate-induced scarcity. When upstream powers control the tap, it pushes downstream, nuclear-armed nations toward active military conflict over basic survival. Geopolitical analysts are now warning about the potential rise of a water cartel. Just as OPEC once centralized control over global oil, water-producing and exporting countries could leverage their vast freshwater reserves to dictate terms to a thirsty world. As Wall Street speculation, AI industrial demand, and collapsing international treaties converge, they destabilize the water security of billions, increasing the risk of large-scale displacement as local resources fail to meet human needs. International policymakers and human rights experts argue the current trajectory requires immediate structural reform. This includes banning bulk water exports, enforcing strict transparency mandates on corporate extraction, and establishing national frameworks that permanently classify groundwater as a public trust. We have built an entire shadow economy around the legal fiction that water can be separated from the land it sustains. To prevent a devastating global conflict, the international community must dismantle that fiction and protect our most vital resource before it is fully weaponized for profit.